Good day, everyone. Before we start, I would like you to meet our special guest, Mr. Isaac Newton. Though he doesn't have Facebook, Instagram, and TikTok, he is very famous, but in the field of science, especially in the field of physics. He formulated the laws of motion and gravitation. Through his 3 laws of motion, we can predict and describe the movement of everything around us. His 3 laws of motion are the law of inertia, the law of acceleration, and the law of interaction. Let's investigate first the law of inertia. We will need an empty glass, a cardboard. You can recycle your old folder and cut it into box. 1 peso coin, 5 peso coins, plastic ruler, then we're ready. For the part 1, put the cardboard on top of the empty glass, then put the 1 peso coin on top of the setup. Let's try to slowly pull the cardboard with your hand and observe what happens. What happens when you slowly pull the cardboard? That is correct. When we slowly pull the cardboard, the coin on top moves with the cardboard. Let's arrange again the setup. This time, quickly flick the cardboard with your finger, then observe what happens. What happens when you flick the cardboard? Can you explain? When we flick the cardboard moved forward, but the coin did not move with it. When the cardboard was removed, the coin dropped into the glass. The coin did not move forward with the cardboard because of the tendency of the coin to stay at rest. Let's compare it when we slowly pull the cardboard. When we slowly pull the cardboard, the frictional force acting between the coin and the cardboard caused the coin to stay on top of the cardboard and move with it. Let's have the part 2 of our experiment. Stack the 5 peso coins on a flat level surface. Then, quickly hit the coin at the bottom with the edge of the ruler. What happens when you hit the coin at the bottom? That is correct. When we hit the bottom coin with the edge of the ruler, it moved out from the pile of coins, but the other coin stayed in place. This experiment demonstrates inertia. What is inertia? Inertia is the tendency of the body to resist changes in its state of motion. The state of motion of an object can be at rest or moving at constant velocity. So in the experiment with the coin and the cardboard, which demonstrates inertia? That is correct, it is the coin. So the coin dropped into the glass because it's trying to remain its state of rest. How about in the second example? How will you explain the behavior of the coins when one of them was hit by a ruler? That is correct. The inertia of the coins has caused them not to move out with a coin that was hit by a ruler. In other words, the coins resist to change its state of motion. All objects have the tendency to resist changes in its state of motion, or keep doing what they are doing. But we can change it. However, changing a body's state of motion depends on its inertia. Inertia is directly proportional to the mass of the object. The lesser the mass, the lesser the inertia. The greater the mass, the greater the inertia, which make it more difficult to move, slow down, speed up, or change its direction. How can we change the motion of an object? For example, the state of motion of the chair is at rest. How can we make it move? That is correct. We can either push or pull the chair. And by pushing or pulling, we are applying a force. Now that we understand what is inertia and how can we make object move or rest, we can now have the law of inertia. Newton's first law of motion, the law of inertia, states that a body will remain at rest or move at constant velocity unless acted upon an external let or unbalanced force. In other words, the law of inertia states that an object at rest will remain at rest and an object in motion will remain in motion as long as no external force or unbalanced force acts on it. We can only change the state of motion of an object if we will apply a balanced force. Wearing a seatbelt is the best example for the law of inertia. If the car you're riding travels at constant speed, bump into a brick wall, the car will stop because of the force acted upon it by the brick wall. However, the driver will require a force that will stop his body from moving, such as seatbelt. Otherwise, inertia will cause his body to continue moving. Here are some other examples of inertia.
Oh, no, 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 no.
I hope you learned something today. See you next time!